Color. LEDs can emit light of an intended color without using any color filters as traditional lighting methods need. This is more efficient and can lower initial costs. Size. LEDs can be very small, smaller than 2 mm to 148, and are easily attached to printed circuit boards. Switch on time. LEDs light up extremely quickly. A typical red indicator LED achieves full brightness in under a microsecond. 149. LEDs used in communications devices can have even faster response times. Cycling. LEDs are ideal for uses subject to frequent on-off cycling, unlike incandescent and fluorescent lamps that fail faster when cycled often, or high-intensity discharge lamps, HID lamps, that require a long time to warm up to full output and to cool down before they can be lighted again if they are being restarted. Dimming. LEDs can very easily be dimmed either by pulse width modulation or lowering forward current. 150. This pulse width modulation is why LED lights, particularly headlights and cars, when viewed on camera or by some people, seem to flash or flicker. This is a type of stroboscopic effect. Cool light. In contrast to most light sources, LEDs radiate very little heat in the form of IR that can cause damage to sensitive objects or fabrics. Wasted energy is dispersed as heat through the base of the LED. Slow failure. LEDs mainly fail by dimming over time, rather than the abrupt failure of incandescent bulbs. 151. Lifetime. LEDs can have a relatively long useful life. One report estimates 35,000 to 50,000 hours of useful life, though time to complete failure may be shorter or longer. 152. Fluorescent tubes typically are rated at about 10,000 to 25,000 hours, depending partly on the conditions of use, and incandescent light bulbs at 1,000 to 2,000 hours. Several demonstration shaves shown that reduced maintenance costs from this extended lifetime, rather than energy savings, is the primary factor in determining the payback period for an LED product. 153. Shock resistance. LEDs, being solid-state components, are difficult to damage with external shock, unlike fluorescent and incandescent bulbs, which are fragile. 154. Focus. The solid package of the LED can be designed to focus its light. Incandescent and fluorescent sources often require an external reflector to collect light and direct it in a usable manner. For larger LED packages, total internal reflection (TIR) lenses are often used to the same effect. When large quantities of light are needed, many light sources are usually deployed, which are difficult to focus or collimate on the same target. Disadvantages. Temperature dependence. LED performance largely depends on the ambient temperature of operating environment or thermal management properties. Overdriving an LED in high ambient temperatures may result in overheating the LED package, eventually leading to device failure. An adequate heat sink is needed to maintain long life. This is especially important in automotive, medical, and military uses where devices must operate over a wider range of temperatures, and require low failure rates. Voltage sensitivity. LEDs must be supplied with a voltage above their threshold voltage and a current below their rating. Current and lifetime change greatly with a small change in applied voltage. They thus require a current-regulated supply, usually just a series resistor for indicator LEDs. 155. Color rendition. Most cool white LEDs have spectra that differ significantly from a black body radiator like the sun or an incandescent light. The spike at 460 nm and dip at 500 nm can make the color of objects appear differently under cool white LED illumination than sunlight or incandescent sources, Due to metamerism, 156, red surfaces being rendered particularly poorly by typical phosphor-based cool white LEDs. The same is true with green surfaces. The quality of color rendition of an LED is measured by the color rendering index, CI. Area light source. Single LEDs do not approximate a point source of light giving a spheric light distribution, but rather a Lambertian distribution. So, LEDs are difficult to apply to users needing a spherical light field. Different fields of light can be manipulated by the application of different optics or lenses. LEDs cannot provide divergence below a few degrees. 157. Light pollution. Because white LEDs emit more short wavelength light than sources such as high-pressure sodium vapor lamps, the increased blue and green sensitivity of scotopic vision means that white LEDs used in outdoor lighting cause substantially more skyload. 135. Efficiency droop. The efficiency of LEDs decreases as the electric current increases. Heating also increases with higher currents, which compromises LED lifetime. These effects put practical limits on the current through an LED in high-power applications. 158. Impact on wildlife. LEDs are much more attractive to insects than sodium vapor lights, so much so that there has been speculative concern about the possibility of disruption to food webs. 159, 160, LED lighting near beaches, particularly intense blue and white colors, can disorient turtle hatchlings and make them wander inland instead. 161. The use of turtle-safe lighting LEDs that emit only at narrow portions of the visible spectrum is encouraged by conservancy groups in order to reduce harm. 162. Use in winter conditions. Since they do not give off much heat in comparison to incandescent lights, LED lights used for traffic control can have snow obscuring them, leading to accidents. 163, 164. Thermal runaway. Parallel strings of LEDs will not share current evenly due to the manufacturing tolerances in their forward voltage. Running two or more strings from a single current source may result in LED failure as the devices warm up. If forward voltage binning is not possible, a circuit is required to ensure even distribution of current between parallel strands. 165. Applications. Daytime running light LEDs of an automobile LED uses fall into 5 major categories. Visual signals, where light goes more or less directly from the source to the human eye, to convey a message or meaning. Illumination, where light is reflected from objects to give visual response of these objects. Measuring and interacting with processes involving no human vision. 166. Narrowband light sensors, where LEDs operate in reverse bias mode and respond to incident light, instead of emitting light. 167, 168, 169, 170. Indoor cultivation, including cannabis. 171. Indicators and signs. The low energy consumption, low maintenance and small size of LEDs has led to uses as status indicators and displays on a variety of equipment and installations. Large area LED displays are used as stadium displays, dynamic decorative displays, and dynamic message signs on freeways. Thin, lightweight messaging displays are used at airports and railway stations, and as destination displays for trains, buses, trams, and ferries. Red and green LED traffic signals and color light is well suited for traffic lights and signals, exit signs, emergency vehicle lighting, ships navigation lights, and LED-based Christmas lights because of their long life, fast switching times, and visibility in broad daylight due to their high output and focus. LEDs have been used in automotive brake lights and turn signals. The use in brakes improves safety due to a great reduction in the time needed to light fully, or faster rise time about 0.1 second faster than an incandescent bulb. This gives drivers behind more time to react. In a dual-intensity circuit, rear markers and brakes, if the LEDs are not pulsed at a fast enough frequency, they can create a phantom array, where ghost images of the LED appear if the eyes quickly scan across the array. White LED headlamps are beginning to appear. Using LEDs has styling advantages because LEDs can form much thinner lights than incandescent lamps with parabolic reflectors. Due to the relative cheapness of low-output LEDs, they are also used in many temporary uses such as glow sticks, throwaways, and the photonic textile Lumilife. Artists have also used LEDs for LED art. Lighting. With the development of high-efficiency and high-power LEDs, it has become possible to use LEDs in lighting and illumination. To encourage the shift to LED lamps and other high-efficiency lighting, in 2008 the U.S. Department of Energy created the L-Prize competition. The Philips Lighting North America LED bulb won the first competition on the 3rd of August, 2011, after successfully completing 18 months of intensive field, lab, and product testing. 172. Efficient lighting is needed for sustainable architecture. As of 2011, some LED bulbs provide up to 150 lm/W and even inexpensive low-end models typically exceed 50 lm/W, so that a 6-watt LED could achieve the same results as a standard 40-watt incandescent bulb. The lower heat output of LEDs also reduces demand on air conditioning systems. Worldwide, LEDs are rapidly adopted to displace less effective sources such as incandescent lamps and CFLs and reduce electrical energy consumption and its associated emissions. Solar-powered LEDs are used as street lights and in architectural lighting. The mechanical robustness and long lifetime are used in automotive lighting on cars, motorcycles, and bicycle lights. LED street lights are employed on poles and in parking garages. In 2007, the Italian village of Torica was the first place to convert its street lighting to LEDs. 173. Cabin lighting on recent Airbus and Boeing jetliners uses LED lighting. LEDs are also being used in airport and heliport lighting. LED airport fixtures currently include medium-intensity runway lights, runway centerline lights, taxiway centerline and edge lights, guidance signs, and obstruction lighting. LEDs are also used as a light source for DLP projectors, and to backlight newer LCD television, referred to as LED TV, computer monitor, including laptop, and handheld device LCDs, succeeding older CCFL backlit LCDs although being superseded by old screens. RGB LEDs raise the color gamut by as much as 45%. Screens for TV and computer displays can be made thinner using LEDs for backlighting. 174. LEDs are small, durable and need little power, so they are used in handheld devices such as flashlights. LED strobe lights or camera flashes operate at a safe, low voltage, instead of the 250 plus volts commonly found in xenon flash lamp-based lighting. This is especially useful in cameras on mobile phones, where space is at a premium and bulky voltage-raising circuitry is undesirable. LEDs are used for infrared illumination in night vision uses including security cameras. A ring of LEDs surround a video camera, aimed forward into a retroreflective background, allows chroma keying in video productions. LEDs are used in mining operations, as cap lamps to provide light for miners. Research has been done to improve LEDs for mining, to reduce glare and to increase illumination, reducing risk of injury to miners. 175. LED for miners. To increase visibility inside mines, Los Angeles Vincent Thomas Bridge illuminated with blue LED sleds are increasingly finding uses in medical and educational applications, for example as mood enhancement. 176. NASA has sponsored research for the use of LEDs to promote health for astronauts. 177. Data communication and other signaling. Light can be used to transmit data and analog signals.